In this lesson, we're going to look at the vertical and horizontal asymptotes and then the x and y intercepts of a rational function. So let's just quickly review what the vertical asymptotes are all about. To find them, you got to set the denominator equal to 0, and then what you end up with is an x equals equation. So it's a vertical line. And depending on the degree of the denominator, that will determine how many vertical asymptotes you have. If you have a second degree function in the denominator, or second degree polynomial, then chances are you'll have 2 vertical asymptotes. If it's linear, you'll have 1. And then yesterday we also talked about horizontal asymptotes. The horizontal asymptote is a y equals equation, so it's a horizontal line. And to find that, it's basically where the function, the value of the function as x approaches positive or negative infinity. So it's the value of r of x as x approaches positive and negative infinity. So it's kind of like the end behavior for a rational function. So what we do is that we look at 3 cases. You can either evaluate your function for a very large value of x, or you can look at 3 cases. And to do that, you have to look at the degree of the numerator and the denominator. So you're going to make sure that your numerator and denominator are both in standard form with the highest degree term first. And then again, you're going to look at the degrees, and there are 3 cases. If the degrees are the same, that means for very large numbers, everything is going to divide away except the leading coefficients. So the horizontal asymptote is just the ratio of the leading coefficients. And then if the denominator is larger, that means the denominator is going to get increasingly bigger compared to the numerator, which means the entire function will approach 0. So in that case, your horizontal asymptote is y is equal to 0. And then finally, if the numerator is larger, there is no horizontal asymptote because the function just keeps increasing. So those are our 3 cases for the horizontal asymptote. And we're going to add 2 more things today. We're going to add the x-intercept and the y-intercept. So the x-intercepts, those are the locations where the function crosses or intersects the x-axis. And you can have more than one. So we can have multiple x-intercepts. So when you are on the x-axis, the y value is 0. So we're going to use that to find out how to find the x-intercepts. That means my entire function is equal to 0. That's where my x-intercepts are. So if you think of your rational function, if r of x is a ratio of polynomials, then when you set that equal to 0, in order to find the x-intercepts, q of x isn't really involved. If you were to cross multiply, he's going to be multiplied by 0, so he's going to go away. So really what you're doing is you're going to evaluate the numerator when the numerator is set equal to 0. So you're going to set the numerator equal to 0 and solve. Now when you are done, you will get a coordinate. You'll have a value for x, but your y value is going to be 0. So you're going to have a coordinate answer. You might have more than one. If this is a sub 1, a sub 2, comma 0, because your y value is going to be 0. And then to find the y-intercept, there's only going to be one y-intercept. Otherwise, we wouldn't pass the vertical line test. But the y-intercept is where the graph intersects the y-axis, and that means your x value is 0. So what you'll be doing is actually evaluating the function when x is 0. So you're substituting in for 0. You'll get one answer, and that's going to be the coordinate where the function crosses the y-axis. So we'll work through a few examples, or at least I'll work through one example to show you the 4 different things, and then we will talk about sketching graphs very quickly. Alright, so we're going to do an example here where we want to find the asymptotes and the intercepts. And here's what our example looks like. R of x is going to be equal to 4x minus 8 over x squared minus 3x minus 4. So we're going to find 4 things. Make sure you label the 4 different things, otherwise I won't be able to decipher what you're doing. So if I start with the vertical asymptote, to find the vertical asymptote, you set the denominator equal to 0 because it's where the function is undefined. So this is x squared minus 3x minus 4, and that's equal to 0. You're going to factor it, x minus 4, x plus 1, and you end up with x is equal to 4, and x is equal to negative 1. So you have 2 vertical asymptotes there. X equals equations. For the horizontal asymptote, we look at the degree of the numerator and the degree of the denominator. The numerator has a degree of 1. The denominator has a degree of 2. Therefore, the degree of the denominator is larger than the degree of the numerator, and that means our horizontal asymptote is the x-axis. Y is equal to 0. To find the x-intercept, that means our y value is 0. We set the numerator, because if I were to set this side as 0, the denominator goes away. It gets multiplied by 0. So basically 4x minus 8 is equal to 0. And we end up with the value of x is 2, but please don't leave your answer like that. It's a coordinate. It's 2, 0. That's the location of the x-intercept. And then finally the y-intercept. The y-intercept is the value of the function when x is 0. So if I'm evaluating r of 0, that means I have 4 times 0 minus 8 all over 0 squared minus 3 times 0 minus 4. You end up with negative 8 over negative 4, and that value is 2. So as a coordinate, it's 0, 2. So these are the 4 items that you had to find. Now, if the numerator were a second degree function, you might have 2 x-intercepts. But you'll only always have just one y-intercept because you're evaluating the function, and for it to be a function, you can only have one output for every input. So that's the basic premise of what we do to find asymptotes and intercepts. Alright, now I'm going to walk you through how we can sketch rational functions without using our calculator. So we're going to list some steps first. So to do this, we're going to find the x and y intercepts, and we're going to plot those points on the graph. Then we would find the vertical and the horizontal asymptotes, and we would put them in as dashed lines. Finally, we would sketch our graph using the points that we graph, the asymptotes, and then some test points to figure out which side of the asymptote the graph is going to be on. So I will walk through these steps with an example here. Alright, so we're going to use the example we just did where we found the asymptotes and the intercepts. We have r of x is equal to 4x minus 8 over x squared minus 3x minus 4. What we found was that the vertical asymptotes were at x equals 4 and x equals negative 1, and the horizontal asymptote is y equals 0. So I can put those in as dashed lines, and x equals 4. If I'm just going to sketch this, I'll lay out some points here. X equals 4 means it's going to be out here. I've got a vertical asymptote, and x equals negative 1. Okay, the next thing is that my x-intercept was 2, 0, and my y-intercept was 0, 2. So I can plot those 2 points, 2, 0, and remember, in the middle of the function I can cross the horizontal asymptote, but out on the ends I don't do that, and 0, 2. Okay. So then we're going to use some test points to kind of figure out what's going on. In the middle, I'm always going to go approach the vertical asymptotes asymptotically, which means I'm increasing this way and I come down and then he's going to be going off that way. So there's the center of my graph. But now I got to figure out whether my ends are either up here or down there on either side. So that's what I got to figure out with test points. If I use, let's say, positive 5 here, if I substitute a value in for positive 5, I'm either going to have a positive value or a negative value, and that's going to tell me which way my graph is going to go. So r of 5, if I substitute it in, I get like 4 times 5 minus 8, and then you have 5 squared minus 3 times 5 minus 4. I don't really need a value. I just need to know whether it's going to be positive or not. But it ends up being 12 over 6. That's positive, which means my graph is going to be up here. And they're going to look like that. In the next part, I'm going to evaluate at negative 2. So r of negative 2, if you substitute all that in, I end up with a negative value in the numerator. Looks like negative 16 over 4, I think over 6. So that's going to be overall negative, which means the other part of the graph is going to be down here. And if you aren't quite sure, like in the middle, what it's going to look like, you can use some more test points just to see. If you evaluated r of 3, then you would get 12 minus 8 over 9 minus 10. That would be a negative value, so then that would help you kind of show you that he's going to be pointing down this way. So we will practice more of these in class. It takes a little bit of getting used to, but the key is to sketch the asymptotes and the intercepts, and then just go from there using test points.